Hi, my name is Alex Williams, founder of the New Stack, and you are listening to the New Stack Analyst podcast. Each week, we look at application development and management at scale. Apcera is a cloud platform that's highly secure, policy-driven, and designed for cloud-native applications and microservices. I first ran across Apcera a few years back when talking with Derek Collison, their founder, who was actually one of the people behind Cloud Foundry. What Derek and his team have done is create a semantic data pipeline. It adapts your IT policies. It removes much of the hassle that comes with application deployment. They say it's plug and play. You plug it in and it's ready to go. Check it out for yourself at Apcera.com. That's Apcera at Apcera.com. Now let's get to the show. Hi, Alex Williams of the New Stack here for the New Stack Analyst Show. This episode is live from Kubecon, and we are lucky enough to have Derek Collison as our guest. Derek is the founder of Apcera. Good to see you, Derek.
Good to see you. And
we have Janakiram MSV, who writes for the New Stack and is a well-known analyst and really has his finger on the pulse of this new ecosystem that we're seeing. So great to have you here, Johnny.
Thanks, Alex.
And so the format that we really use for the New Stack Analysts is we'd like to just hear from Apcera, what the company is about to help explain it to us, and then we'll just go there and into a longer conversation.
Sure. So Apcera was built and architected about 3.5 years ago to deliver a trusted cloud platform. And trust is kind of a word that's hard to define, but you know when you don't have it, right? It's very obvious. And in today's worlds where software systems are becoming more and more complex, that complexity usually breeds risk, right? And so what we want a platform technology that actually drives risk down without affecting speed and agility, right? So speed and agility and then being safe are these two opposing forces that most people think can't be resolved. And Apcera is trying to resolve those two by allowing developers and DevOps to actually go at speed, go with the opinion that they have on how they actually develop and deploy applications and software systems, but have a platform system, essentially a trusted platform system that brings together the notion of security and compliance and governance and trust.
So Johnny, I know you were wanting to ask Derek some questions about Apcera, and I think what we really want to do here is get a full picture of Apcera, and a lot of that comes back to talking about the people and who they are and where they've been before, and so I think Johnny had some good questions around that. So why don't you?
Sure. So for those of you who are not familiar with Derek's work, he along with Mark Lukowski actually developed Cloud Foundry back at VMware almost in 2010. So I'm very curious to learn from Derek on how he sees the PaaS ecosystem evolving from the time you built Cloud Foundry to the current context of containerization and orchestration. So how did you see PaaS evolving? And then we'll try to understand more about Apcera.
Sure. No, that's a great question. And at the time when myself and Vadim Spivak and Mark Lukowski moved from Google over to VMware, we were looking at a different set of problems in a different world where developing applications was complex, but it was becoming easier with things like Ruby on Rails. But the deployment of said applications was still difficult. And you started seeing this emergence of something called platform as a service, which was a fancy way for saying a very opinionated way of just give me your app and I'll figure out everything else for you. The issue was that they were the entrance into the market, which was very, very early, were very specific. So you had Heroku Garden pivot into Heroku, which was cloud only, and Ruby on Rails only. And then within Google, although neither myself, Mark, or Vadim worked on it, was Google App Engine. But again, it was Python, no such thing as a relational database, and all in the cloud. And so the concept around Cloud Foundry originally was speed up deployment of complex modern applications that are applicable to the enterprise. So it could be written in Java. Want to talk to a relational database, which sounds normal for anybody doing enterprise development. But at the time when these newer technologies started to emerge, those were kind of left out in the cold. And so, the project internally was started to specifically solve, and empower development operations inside of an enterprise using the tools and languages that they already know.
Right. So fast forwarding to 2015 and in the world of Kubernetes, we're actually seeing the same concepts. For example, in Cloud Foundry, you had the droplets and droplet execution agent, followed by an orchestration layer at the top. And today, when you look at Kubernetes, they have kubelet, which is almost the same agent infrastructure that's inside the VM, a node, and you have the same container orchestration. So does it mean Kubernetes is bringing some kind of a standardization to pass that was missing in the early days?
It could be. I mean, platform as a service has been radically redefined since the early days, in 2010 or so. What we're seeing is an emergence of different patterns, but what remains constant is the ability to orchestrate and manage infrastructure at a layer that meets developers where they're at. I think that's still a fair characterization of all of these technologies. Now, what becomes really interesting is that when you look at the system in totality, all right, there's lots of moving pieces. It's like, how do you actually deploy a workload? What does that workload run in? Where is it allowed to run? What can it be made up of? And at least for us, very specifically, what is that workload allowed to communicate with? So remember when I first started out, it has to meet developers kind of where they are now, right? And that's that abstraction layer that people care about. And that's a very different layer of dev and DevOps interaction than an IT ops interaction, which is still understanding machines, low-level networking, right? And so we need technologies that, one, bridge that gap. For Apcera, what we tried to do is we made sure to take the problem and stand it on its head and build in transparently all of the fundamental pieces that can drive security, compliance, governance, trust, which are usually bad words, right? Nobody wants to hear those words. But the platform, the way it actually does that is it has a decision system, a policy system, that cares deeply about four things. What goes inside of something you deploy? So think of it as layers in a Docker image or packages inside of an image. And being able to control those, whether or not you're doing something in dev test, production, whether it's you, me, or Alex, all the rules are probably going to be different. Which version of Java is allowed? Which version of a service that we want to talk to? So that's number one. Number two is, what can that workload job use in terms of resources? And that's table stakes. So containers do it, VMs do it. The hybrids like clear containers, right, where it's a lightweight KVM with a container inside. They still do the same type of blocking and tackling. They're trying to isolate a workload, provide some level of security, and put quotas and SLAs around things. And I think, through the OCI, we've seen a tremendous amount of progress around standardization from that point. But that's number two. There are two left, and then Alex, I know, wants to jump in. Number three is, where can a workload run? Where is it allowed to run? Can it run on-premise? Does it have to run in Amazon? Does it have to run with this specific pieces of hardware? Does it have to run close to you? Does it have to run far away from Alex? All those types of things mean you need a policy-aware resource scheduler, right, a scheduling algorithm. And then the last one is, who is the workload allowed to talk to, and who can talk to it? It's a network programming layer. What's interesting about Apcera's approach is that instead of picking one or two or even three of those things, we picked all four, put a policy engine on top of that, and then built platform technologies that enforce every single one of those consistently on any public cloud and any private infrastructure. So now all of a sudden you're starting to look at a system where it's like, I just want an OS, or I want to deploy a Docker image, or I want to deploy an application and have the old style PaaS kind of in effect. But I want to be able to do it layered on top of OpenStack, vSphere, some resources in IBM software, Amazon, Google, Microsoft's Azure. And I want to do it in a consistent and enforced way that drives trust. For us, starting 3.5 years ago, we did not see anyone that want to take on all of those problems in totality. We see people that want to take on one or the other, and then eventually it gets to the point where they go, we got to bolt on some stuff to drive trust. And you'll see that by saying, oh, we have policy. Well, they have a policy that can decide in a very, very small context about whether or not you're allowed to do something, but they're not going to enforce it, meaning whether you're doing it maliciously or accidentally, you can easily subvert most of these. The bigger problem that we see is that we're seeing islands of these. and it makes it very hard to reason about how a workload, in Apcera would necessarily talk to a workload running on Mesos or Kubernetes or Cloud Foundry or OpenShift or XYZ, or to the Hadoop cluster or the Spark cluster or a MapR installation. So rationalizing these things together makes sense for companies because it drives business. It drives I feel safe allowing all these things to go along and I know who can access what. But it also allows them to utilize any type of infrastructure, any type of service in a way that, at least from our perspective, hasn't been seen yet.
So how does that reflect on how contracts around software have changed? And I was talking earlier with the people from DAIS, and I asked them to, help the the community out there understand more about application architectures and microservices. And they used this context of contracts around software. Basically, there's a set of contracts that comes with developing a microservices, right? And so I'm curious from your perspective how those contracts have changed in terms in application architectures, and how you view them philosophically now with Apcera and just otherwise.
Good software design always has a good API contract, right? And there are certain rules that people who have been doing this for any amount of time recognize, which is once you have a contract, you can't break it. You might be able to add to it, you can't take away from it. Right. And if you radically want to change it, you got to come up with a new contract.
Right.
That's applicable to if there's two big fat Java apps, each using 8 gig big, or in a world where microservices, in my opinion, SOA 2.0, we've been there, done that, is really starting to take root simply for the fact that two things exist. The isolation context, which now the flavor is containers or hybrid containers, are lightweight enough to spin up lots of these without an additional cost. So one of the ways I've talked about it is, let's say you used a VM and it takes 2 minutes to spin up, and you run a 4 gig Java app and it runs for years. There's no reason necessary to move away from a VM.
Right.
But what happens is that with containers, with getting faster, better and cheaper, all of a sudden your behavior starts to change. And now all of a sudden it's like, oh, I want to spin up something that might run in 8 mega memory. And it's going to run for 10 minutes and then be torn down. I think some latest data on Docker image deployments have shown that the lifetimes are very short. And that behavioral change is because there's now an isolation context that can spin up that's lighter weight, faster, and it's okay to spin it up and tear it right down because it comes up in less than a second. Now what's happening is that same basic construct of, hey, good software design, you have good contracts between any pieces that interoperate, is now being exploded because we have the container technology that allows the behavior change. We have the platform technologies, one being here, right, Kubernetes, that allows all that undifferentiated heavy lifting to be driven into the platform, so I don't have to worry about trying to coordinate 15 different subcomponents all scaling independently, right? And so now all of a sudden there's just a tremendous amount of pressure on, hey, we have to make sure our hygiene around APIs and the contracts between these services is clear. It's not anything new, it's just kind of more in your face, and it's easier to get bit if you don't do it the right way.
Right. So going back to your policy-driven execution and the key differentiator of Apcera, I want to step back a little, and if you traditionally look at PaaS, there are two aspects that the developers would bring to PaaS. One is their own code, and then there is metadata. So the metadata will define the runtime characteristics of the app, the dependencies, how it would discover the database or other persistent engines. And you submit these two to a PaaS engine, and the PaaS would take it up and provision and schedule your entire app, right? So in a lot of ways, the metadata already had some policy that defined placement rules, that defined characteristics of the app and some dependencies. So is my understanding clear that Apcera takes it to the next level by giving much more granular policy that goes as a part of the metadata and augments that whole thing to the next level?
Well, I think the separation comes between what DevOps cares about and what ITOps cares about, and more importantly, what the business cares about. And I'll highlight this with an example. So when I was at Google and writing an application, I knew what the dependencies for the application were. And there was, inside of Google, metadata that allowed me to describe that. And I had my own policies with double air quotes around them about SLAs and quality of service for my application. Now remember,
was that common to do that?
yes, that's the way you did it
Yeah.
inside of Google. What becomes very interesting is that inside of Google, you didn't talk to machines, you talked to an intermediary. And the intermediary understood policies at a business level that I didn't understand, nor should I understand. And it could enforce those and blend the execution of what I was trying to do with a fungible set of assets, essentially underneath, and what was driving the business. Now, at the time I was there, that policy was very crude. It was, you can do whatever you want as long as you don't interfere with search and ads. And if you're interfering with search and ads, you get bonked on the head and you lose. I mean, hopefully that makes sense to all the listeners and stuff of how that would be. Now think about it in an enterprise. There may be rules around data sovereignty. Who's allowed to access, a database? What SLAs they're allowed to if they're running a test? Having developers try to internalize and understand that and effectively implement that is a recipe for disaster. It just does not scale. And so I think you need a blend, right? You need the platform and the business owners that are cross-functional to be able to have policies that can execute these rules on behalf of the business while still letting the developers essentially run at full speed with kind of bumper guards that if they don't hit them, they don't care. But they've got to be there, right? So floor-based network SLAs, access to databases no matter where you're running. So it'd be interesting if the business says, hey, there's a whole bunch of these jobs running that if we put them out in Amazon with this certain characteristic, we can save a lot of money. But they're allowed to access the database, but only they're allowed to access the database. If you walk through that methodology with inside of an existing organization with how they're built today, coming to the decision on a spreadsheet, wow, we could save this much money. Now let's see if we can execute it. Let's get NetOps involved. Let's get SecOps involved. We got to hire people to spin up this stuff on Amazon. You actually lose all of the savings that you were thinking you were going to get. But if you have a platform, right, that has the ability to enforce all of those totally consistently, you can trust it. And instantaneously add resources in the public cloud and click a button in less than 2 seconds, all those workloads are running out there, securely accessing a database on-prem. That starts changing things. So the same push into microservices, we are changing our behavior because of the things that we've been presented with. I think a platform that is truly multi-cloud and trusted presents you with opportunities as a business to do things that you might not do today.
Got it. So is desired state configuration a part of your policy? Can I define how many instances of my app is going to be running at any given point of time? Is that a part of the policy?
The simple answer is yes. The more appropriate answer is, again, there is a balance between what the developer is trying to do and what the business cares about.
Right.
So, for example, the developer might say, hey, I want an SLA, response time under 100 milliseconds, and if I'm not getting it, scale up everything until I get it. And that's reasonable for a developer. On the IT ops business side, they say, that's great, let them do that, but if they hit 100 machines, cut them off, because we don't want a $50,000 bill when their algorithm kind of goes crazy. So it's that bumper guards, right? So policy in our system would say, there's going to be metadata talking about how many instances you want. Policy will say what you're allowed to do or not to do.
Got it. So stepping back a little, again, from the landscape perspective, there are some interesting trends, Derek, that we are seeing. For example, on one side, we are seeing Kubernetes implementations and application orchestration tools like Tectonic, right? And Joins, Triton, and even Helm that was just announced yesterday. None of them call themselves as PaaS. They are container orchestration engines, and they're positioned that way.
And Red Hat is moving away from the term PaaS.
Exactly. And the traditional PaaS has been reduced to a wafer-thin layer on top of container orchestration, just delivering developer experience. So does it mean the lines between container orchestration and PaaS are getting blurred? Are they going to be relevant in the future, or would it be just converging into one application orchestration model?
Well, I think, you raise a good point. Obviously, about 2.5 years ago, I said PaaS was dead, and I think what I meant was it was being radically redefined, and you're kind of highlighting that now. What a developer wants to do and how they want to do it, interact with the system, they have an opinion, and at the end of the day, the only opinion that matters is theirs. Now, I'll caveat with that because I built a very opinionated system, back in 2010. The reason that it worked, and it worked for a certain period of time, in my opinion, is developers were willing to give up that control to get the speed. But if they can have the speed and have their opinion, right, that's all they ever want. And so what I think we're seeing is that it's not necessarily just orchestration. Orchestration is one component of what I think are the 4 tiers of a management platform. Whether you call it container management, cloud management, I don't care. It's going to keep changing. The management platform in a true multi-cloud sense is what's important, at least from Apcera's perspective. And it is deeply rooted in 4 fundamental things. What can be inside of a workload, so think zero-day exploit, what's your base layer that you're allowed to run in development, those types of things. Being able to have control over that in a way that changes based on its dev test, or if it's Alex doing something in production, or if it's me doing something with the Hadoop cluster. Pillar number 1. Pillar number 2 is what can the job use? Memory, CPU, disk, network. And from our perspective, you have to be able to enforce all of these, right? This is the difference, I think, with the Apcera platform. But I think in general, all platforms have to concentrate more on management piece, and they have to do those 4 things. For us, CPU and network are floors, meaning you can spike and use more if it's available, but otherwise you're cut off. Memory, I know Kubernetes now allows overcommit. I've never seen that work well in production. When things go wrong, it's very hard to figure out. So we don't do that. And then number 3 pillar is where can things run? So a scheduling aware or policy aware scheduling algorithm. So whether it's Mesos is underneath algorithm, Federation, Kubernetes, Diego, at the lowest layer, that's interesting but not sufficient. What becomes very sufficient is it efficient in how it's using resources, and is it aware of policies of where things are allowed to be placed based on role, personality, the identity of the system itself, right? So it's you deploying the same app into production is very different than you deploying V2 of that app into dev tests.
Now let's take a quick break before we get back to the second half of the show. Apcera is a cloud platform that's highly secure, policy-driven, and designed for cloud-native applications and microservices. It adapts to your IT policies. It removes much of the hassle that comes with application deployment. You plug it in, and it's ready to go. Check it out for yourself at apcera.com. Now let's get back to the show. So now we're in a world where developers don't necessarily have to give up control, but they still have to be balanced according to their own SLAs, right, and the business requirements.
Yes.
So that's a new working way to think about PaaS in some respects.
I like I said, I think even the PaaS vendors aren't calling themselves PaaS anymore. So I think we can write that off as Derek had it right. I was just 2 years early. But one last thing is that 4th pillar, which is the most important one, is who can talk to what. Do you have a truly programmable network that's enforceable, that is visible and can move at speed at the developer and DevOps layer, not IT ops speed? Not do I put a request in, you get back to me in lightning speed of 4 hours. You need something that can program itself on the fly, self-heal itself on the fly in less than 5 milliseconds, consistently across any multi-cloud, public cloud, private cloud, whatever. And that's a really big one, because then all of a sudden, most systems these days are, the compromises, you'll hear about zero-day exploits, but it's only to get in so that then they can access something that the software system is allowed to access.
So it's the speed at DevOps and the speed that developers expect,
Sure,
as opposed to the speed that has traditionally been,
anything
equated with IT ops.
Yeah, can I have a DNS entry? Can you change the firewall rules? Can you open up a port? We essentially believe that every workload should have a firewall of one that is programmable on the fly at wire speed, totally distributed. And so one of the things within the Apcera platform that we delivered on from day one. That's why it took us so long, 3.5 years ago. We have one of those. But the end effect in itself is interesting, but not sufficient. It's the fact that it's the enforcement plane for the ability for us to reason about what workloads can talk to or not. And it's all, all 4 pillars are what I believe makes up a true modern management platform, whether you call it container, cloud, whatever it is.
Got it. A couple of more questions on Apcera's architecture. So how do you manage stateless versus stateful? How do you manage persistence within your PaaS?
Well, good. We're not going to call them PaaS anymore. But I will point out this. So as we talked about the notion of opinion versus unopinionated, of how developers want to work with these technologies, right? One of the things that's also changing very quickly is the PaaSes of the 2010s, for the most part, said modern applications go inside, anything stateful goes outside. Right. And you're hearing people hold on to this almost in a dying, not healthy way by jumping onto cloud native and 12-factor, right, where most everything is stateless. That's not the modern world. That's an opinion that's not going to keep translating. So are the legacy masters of record going into these systems? Probably not, right? Your Oracle database will sit there. Your mainframe running some customer stuff will be there. But what you are seeing is that it's not good enough for a large infrastructure like this to not be able to run stateful applications and stateful services. And so you're now seeing, Docker started it with the common tarball format where all of a sudden it was like MySQL. Oh, you can run MySQL in Docker. Kind of didn't work because the disks were kind of going away, but they're solving it. And I think it's solved now in terms of an offering in 1.9. I think, I might be wrong. Kubernetes, right, has the notion of how do you actually have a persistent volume follow you around. But then if you look at things like Hadoop and Cassandra and a lot of these other technologies, they just need a bunch of disks. They don't need it to follow them around. Yet what they present as a service to applications is something that is stateful and won't go away. Yet all of this now is running in the platform. So I think that the days of apps run inside, services are running outside is going away. And I think that is akin to, one, people were asking a good question, which is why? Why can't you solve this hard problem for us and make it easier to do? And I think with ecosystems around, Kubernetes and and Docker. And by the way, one of the other fun things to talk about is this alignment of Docker, it seems, around dev and DevOps and that tool chain. And then production, it's Kubernetes, Mesos, the Apceras are starting to line up. And each side is fighting for the other one, which is very interesting to me. It's very apparent here at Kubecon.
How do you see it?
I think Docker has a tremendous amount of momentum. I honestly believe Docker is a tarball format for complex workloads and an ecosystem where vendors are willing to stand behind those, so you don't have to stand them up and configure it, which is huge. The biggest question I come up with, though, is...
Docker's a tarball format for complex workloads.
It's the new tarball format for complex workloads, and they've put an ecosystem around it, and most importantly, it shouldn't be lost, vendors will support that packaging of things that are usually hard to set up, MySQL, Postgres, things like that. The question for me is, even though they have a lot of momentum, is it more reasonable to think that they can solve very complex distributed systems problems before Google can figure out how to generate a packaging ecosystem? That's, at the end of the day, that's kind of where we're at, right? I mean,
and Docker is trying to...
Swarm, networking layers are trying to solve complex distributed, workloads. And they have smart people, but Google has a lot of smart people as well who've done this. And I'm just positing what's the easier problem to solve.
So we've seen the packaging formats going through, some standardization to some extent. Is that an example of...
The de facto standard is a Docker image. Everyone has to run a Docker image, even if they want to run other things.
But now we're seeing OCI.
OCI is the container runtime. It has nothing to do with the packaging format.
And that specification. But then what's that packaging piece that you see Google starting to build out?
I don't know if they are or not. I just am questioning both us and the listeners of what's the harder problem to solve.
What signs do you see signs of it? Do you see, we definitely see evidence of Docker with Swarm,
Of course.
They're
trying to go over and cross the chasm into production and IT ops land. with something that's not just running on a single machine.
So do you see any signals of Google going into dev and dev test land?
Well, if you look at the fact that they've talked about packaging formats, Helm, right, of days is kind of a packaging thingy. The manifests that Kubernetes understands of how you describe, the workloads and how they work together. If you look at that, that is important to them. The actual individual workload and how it's packaged, what it's made up in, is probably not as important to them. But again, we'll see how it all plays out. But there is this very interesting theme that I've seen with customers where we've always thought and believed that developers and IT ops would merge and that you would essentially do the exact same thing in dev, test, and production. And I think traditional enterprises are so rooted in you do it one way in dev, test, and you do it in another way in IT ops, that even as Docker has taken hold in terms of mind share, and this is how we kind of develop and deliver software, it hasn't translated to the broader Docker ecosystem of what you do in production. People have had to fill that gap. So Docker as an imaging format and developing software that way was way ahead of the swarm tech, which meant that if companies wanted to adopt it, they needed to figure out what's our answer over in production. How do we deploy a Docker image in production? Hence, Mesos kind of coming back onto the scene. Kubernetes gaining a lot of momentum, plus the fact that it's from Google, which always helps. So I don't know the answer of how this is going to play out, but I am recognizing this kind of positioning.
So now, Kubecon comes at an interesting time. It really speaks to the maturity of the market, which I think you could not have basically said what you're saying, 6 months or a year ago, right? Yeah. About the kind of the split between IT ops, for example, and the developers, right? And how we're starting to see that play out, in this new ecosystem, right? So, with that in mind, how are you helping make sense of the market today for yourself as you're here at an event like Kubecon?
Good questions. One of the things I think we at Apcera are good at is trying to identify trends. So we were part of the very first Go conference, and I was one of the very first people to start pushing to use Go to power a lot of these technologies. We were at the very first DockerCon, and we are here as a premier sponsor for the first KubeCon. What we're trying to do for our customers is rationalize the different technology sets, and whether or not you're in a toolbox mentality of you want tools in the toolbox that you can build it yourself, or you want someone to assemble a trusted partner to put those together and drive business value, and translate that through technology, obviously, but it's more about the business value. So that's the opportunity that we see for our customers. But as the technologies are maturing, and I agree with you, 6 months ago we wouldn't have been here per se. That's the reason that we're a premium sponsor here at KubeCon. There is something going on here. And we are also at the first DockerCon and the first Go conference. So those technologies, and you're starting to see an ecosystem. I mean, we have over 500 people here for the very first one. Docker had about 500 the first time. Go had about 500, and all of them have really taken off. How they all blend together, though, is anybody's guess. But I do know that customers' business value is still deeply rooted in we have to go faster, we have to innovate or die, and we have to figure out a way to do it in a trusted way. We can't get out there and risk our customers' information, our own IP information, or be susceptible to attacks.
How do you see the evolution of Kubernetes versus Mesos and other orchestration style environments? I mean, Mesosphere describes itself as a data center operating system, and Kubernetes doesn't call themselves necessarily an operating system at all. They consider themselves more of a cluster manager. So how are you viewing kind of the story about Mesos, the story about Kubernetes, and how it fits into this this demarcation that you're talking about with IT ops and dev and test?
Yeah, I think the notion of being able to describe and schedule workloads on a large set of resources again, is a very interesting but not sufficient to drive business value problem. And so I think one of the things that became clear to me with Mesos was that the least important part of it was the actual low-level resource scheduler. It was the fact that they could do complex workloads with a click of a button, deploy Hadoop, deploy Cassandra. They added the Kubernetes API, which started to gain momentum for them very quickly within an ecosystem that was starting to pay attention. Make no mistake of why Kubernetes was kind of pushed early on as an API, not as a pure Google implementation per se. I'm not saying there's not technology that's flowing from inside of Google's battle-tested Borg and some of the newer Omega stuff, but they concentrated on the API because they wanted to drive a consistent ecosystem that could be run on any cloud, not just their own. That wasn't by accident. And so I think Mesos is drafting off of that momentum as well. For us, when we talk to customers though, if you can't figure out a way to trust it, and again, those 4 pillars are the things that I think everyone eventually agree upon very quickly with any partner conversation, customer conversation. They're like, yeah, we need to control what's inside of there, zero-day exploits. We need to control what it consumes. Yeah, we really want to control where it gets placed. So we can say, hey, run it here, run it there, don't do this, can do this. And then the big one is that network, right? Network is an ecosystem bolt-on on all of these plays. Mm-hmm. And so we've had so many customers that have come and said, we really like this, and this about X, Y, and Z. But then we actually dig a little bit deeper and there's no control of the network. Or if there is, it's limited and it's not actually connected with all of the other things we care about. And so we start talking about those 4 pillars and they go, yes, that's what we're talking about. We go, great, we have that.
So you talk about the bolt-on of the network. What are some of the outcomes you're seeing from that, from the bolting of the network?
Well, you have different patterns that can or cannot be used with different workloads.
Right.
How you actually control access, who's allowed to access what, again, becomes very different. It's not, as we were talking earlier about how you would describe the workload and the system. It's now all of a sudden you're down in a deeper layer somewhere talking to a pluggable network layer that has different rules for how you would set up their version of an SDN or a VXLAN or whatever that is. And then you have to stitch the thread back to, okay, this will work because we'll make sure this app gets deployed inside of this construct that we just set up. Now the first problem is it's slow. Not the network technology per se, but just that process is slow. 2, it's flawed. There's a person in between trying to match what the developer is trying to do with being able to all of us access each other, and then you can talk to the database but no one else can, to these lower level constructs in the low IT ops layer. And anytime there's a human involved, there's going to be issues. It's just we're flawed, and we're the ones that always are fat fingering something, accidentally hitting something wrong. And that's just the way it's going to be. And so not necessarily saying these technologies shouldn't exist, but they should be automated at an abstraction layer and enforced consistently that's driven from a higher level, not all the way down at the IT ops level.
How do you view it, Johnny, the evolution right now? How do you view the market right now here, being here at Kubecon, and what are some of the themes that you're thinking about as it relates to what Derek is discussing?
Right. The first observation that I made is the changing face of PaaS. Right? That's a key takeaway from Kubecon. I think everything is converging towards one theme of application orchestration. So the definition of PaaS has changed. I'm not even sure if it is relevant in the current context of Kubernetes and managing Kubernetes. So increasingly there are tools that are evolving to manage the complex Kubernetes clusters. So essentially the vendors are building a meta cluster to manage multiple clusters. And that is obvious from, for example, CoreOS Tectonic and even Joint Triton and Dice and Helm, and even what Kismatic is trying to do. None of them call or use the term of PaaS. So essentially everyone is building a meta cluster management layer, and that seems to be the future.
Well, and that goes back to, one of the things that intrigued me when I first wrote about what you were doing at Apcera when I wrote at TechCrunch was we were talking about this whole idea of a semantic pipeline, right? And that's the theme I'm hearing more about, is like this idea of semantics, like, and the needs to be able to express yourself. right? And so you can express yourself. We hear that in terms of different ways. We hear that in terms of schedulers, right? There's like discussions about the semantics of schedulers. We hear that in terms of the semantics of the network itself, right? We hear that in terms of semantics of like, helping people express what their workloads are so the cluster manager can know what to do, right?
Yeah, I mean, eventually, I think where everyone is trying to get to, and these are just technologies trying to help us get there, is what is the best way for me to describe a complex system and the QoS and SLAs that I want associated with it, and then hand all of that to some technology that just figures it all out. And then when I rev it and I've got V2, no downtime, the system understands, canary it, slowly move it, A/B it, whatever that is. We all, I think, want the same thing, and we're slowly marching along that path. And so there was, massive footholds around, hey, we got to standardize on how we package these things for an individual workload. Right? Docker saw that opportunity and did an amazing job with seizing that. How do we actually control the workload, the isolation around the workload? Let's go with containers. VMs are too heavy, and there's all kinds of issues there. And that's kind of taken hold, and there's a tremendous amount of exploration and advancement in tech and standardization now around that. So here's the kicker, at least for me. The next phase, which everyone knows is coming, is, oh no, now we have to orchestrate a whole bunch of these things together to actually do anything useful. Kubecon, that's why we're here, right? Kubecon did a better job, or Kubernetes did a better job early on than Docker did at enabling those types of scenarios. But I can promise you where this is all ending up is that once we get all this up together and running, everyone's going to start going, oh crap, what about security and trust and compliance and governance? And they're going to try to bolt crap on top. And Apcera was founded of saying, we just don't believe that ever works, and that you have to flip the model on its head, and you have to, when you're pouring the foundation, you have to build in all of these wires. They might not be connected, but you have to build in all these wires of all the nasty words like compliance and governance. And so we believe that we know how this story is going to unfold. I never know the timing of when they're going to happen. And so we're trying to figure out how could we play a role in the ecosystem to help get some of the things that we believe deeply in, and our customers, and I think Kubernetes and Docker customers do as well, bake some of these ideas into the foundation that can drive trust. So you don't even need the speed, you need the trust as well.
To think about it more holistically.
Mm-hmm. And you have to do it in a way that is as transparent as possible. If every time we do something I say, you're going to love this, you just happen to change your app, and I know you have 4,000 of them, so let me know 6 months when you're done. Oh, we just changed something else. You're going to love it, but you got to change your app again. That model, which is very popularized by what Netflix did, is very much a throwback to the 90s, which is interesting to me because it's counterintuitive to kind of the way DevOps and millennials these days think, which is, hey, I can bring my own device, my own language, my own toolkit, my own process. Yet the way Netflix gets trust is they say, well, they do more now, but at the time, you can only build in Java, and you have to link against all of our libraries. And every time we update them, you have this much time to update it or else we'll update it for you. That's a very throwback to the 90s way of doing consistent, trusted computing, but in a cloud type of an environment. And so it was very interesting to me, and Adrian and I have had some interesting conversations about the dichotomies of what was going on there. But I don't think...
What are some of the things you talked about?
Just the fact that they were so forward-thinking in terms of using cloud and moving from CapEx to OpEx and services-based, even though their container format, their Docker image was a whole AMI at the time. But I said it was so interesting that the way they achieve trust is very strict process, only one language, have to link against all their libraries. And so the reason Adrian, actually spoke with us and advised us for some time was I showed him Latency Monkey that was totally transparent in our system. Where you didn't have to change the operating system, a Ruby app, a Node app, the database, or anything to inject Latency Monkey on the fly at speed with nothing going down. And he kind of went, oh, wow. And so
clusters and monkeys, I think
clusters
it's
and
a
monkeys.
theme over the years.
Latency Monkey was the important one, not Chaos Monkey. But the thing is if you pour it into the foundation and you take the time to make it transparent, right, where you can enforce these things like the network topologies and who can talk to what and what's allowed inside of a workload and what it can use, and be able to change those on the fly, totally independently of the developer, picking his language, building the code that makes the most sense for what he or she is trying to do and driving value to the business and deploying that faster. That's kind of the holy grail that I think all of us are trying to get to. It's just nobody wants to start with the not fun stuff first.
Well, Derek, thank you very much for taking some time to talk today at Kubecon. This is an interesting and important event, and I'm glad you're here to help make it happen. I really appreciate it, and I always enjoy the time, and I can promise you the conversation will continue, and this will keep evolving. It's the speed at which technology is evolving is so fast that even 1 year from now, it's going to be another interesting conversation. And Johnny, great to have you on the show as a guest analyst. It's great to have you part of the new Stack and its development through the writing you've done for us. So thank you very much for that.
My pleasure. Thank you.
Great. Well, thank you guys both, and we'll talk to you again soon. That's it for this week's show. Thank you very much for joining us. I'd like to thank our sponsor. Apcera is a cloud platform that's highly secure, policy-driven, and designed for cloud-native applications and microservices. Check it out for yourself at Apcera.com. That's Apcera at Apcera.com. Audio editing and sound design for the new Stack Analysts podcast is provided by Broken Hours. You can find them at brokenhours.com. Thanks again, and hope to see you back at the show. Bye-bye.